Okay, next type of organic molecule we have is what we call a cyclic hydrocarbon. So, similar to alkanes, enes, and ines in that they have just C's and H's for the most part, the difference is how they're put together. So all the ones we've looked at so far have kind of been like a straight chain or a line with maybe some branches coming off of it. As the name suggests, these ones are going to be carbons that are arranged more in a circle, and we do use cyclic somewhat loosely. It tends to be like a triangle if there's 3 carbons, a square if there's 4, like a pentagon, a hexagon, all those different types of shapes, okay? So, name-wise, we still have 3 parts. We still have a root, we still have a suffix, we still have a prefix. So in this case, the root is going to be how many carbons are in the ring. To indicate that they're in a ring, you're going to use the word cyclo, okay? So in front of the root, you're always going to have that cyclo in front of it, right? So if I tell you cyclopentane, that's telling you to take 5 carbons, put them in a circle. Whereas if I just tell you pentane, that's just 5 carbons in a straight row, okay? So that cyclo part is important. Okay, your suffix, basically what kind of bonds do you have? If everything's a single, it's going to be an ane. If you have a double, ene, a triple, ine, okay? When it comes to numbers, okay, it says in your notes that no numbers are used to indicate the location of those multiple bonds. That's only true if there's just one double or one triple. If you have more than that, then you are going to use that, okay? The reason our rules change a bit with numbering when we get into cyclics is if you think about a circle, there's no defined spot for you to start a 1 at, right? There's no like, oh, this end or that end. It's just a big circle. So technically, you can pick anywhere to be number 1, which is why if I only have one thing, whether it's a double bond or a triple bond, then I don't actually need a number, right? If I only have one thing, technically it's automatically going to be in that same spot, right? Even if I rotate the picture, right? I could ask you guys all to draw something. If you put it in a different spot on the circle, it wouldn't matter because if we rotated the circle, it would be the same, okay? So what you find is if there's only one special thing, whether that special thing is a side chain, a double bond, or a triple bond, you don't need numbers. If there's more than one special thing, then you are going to use some numbers because obviously we need to know where they are with respect to each other, at which point you're going to follow order of priority to assign number 1, right? So remembering back, we said first priority out of what we've covered so far is going to be that triple bond. Then it would be a double bond. Then it would be our side chains in alphabetical order, okay? So if you have more than one special thing, figure out which one of those things is the most important. That gets assigned number 1. You then can either number clockwise or counterclockwise. What will make that decision is what gives you the next lowest number, okay? We'll look at some examples to show you what that looks like. Okay, so looking at some of those examples, okay, we have 2 examples here, okay? So we can start with the one on the left. So you're going to find a lot of the times when we get into cyclics, we start getting into those kind of hybrid line diagrams. And it's just because it gets really annoying to draw all of these H's, right? If you think about, oh, there's an H here, and there's one here, and one here, and one here, one here. You wind up with all these H's kind of mashed together in the middle. So we tend to just not really do them, okay? We tend to do line diagrams. So I'm going to start by figuring out my root. We said the root would be whatever your circle is, right? So here's our circle, right? It has 1, 2, 3, 4, 5, 6. So it's a hex. Because it's in a circle, it's going to be a cyclohex, right? So we're starting to develop some of this name, right? Cyclohex. Cyclo because circle. Hex because there's 6. Okay, when we look at these bonds, everything is a single, so it's a cyclohexane. Okay, now we have 2 side chains, right? We've got this one, then we have this one. So this one up here has only 1 carbon. That means it's going to be what we call, a methyl. The other one down here has 1, 2 carbons. That means it's going to be an ethyl, okay? So priority-wise, we look at the two, they're both alkyl side chains. When it's just alkyl side chains, we follow alphabetical order. So that means the carbon in the circle here gets to be number 1 because ethyl alphabetically comes before methyl. So if I number clockwise, we have 1, 2, 3, 4, 5. So this methyl would be at 5. If we number counterclockwise, 1, 2, 3. So because a 3 is less than a 5, we're going to choose to number this way, okay? So when we go to put it all together in the name, we go alphabetical. So we're going to have 1 dash ethyl dash 3 dash methyl. Then we're going to have that cyclohexane, okay? All right, so now we look at our other one over here. So it's also a hex, right? We have 6 carbons in here. The difference now, though, is this guy here. We have a double bond, right? So this isn't going to be a cyclohexane. This is going to be a cyclohexene, okay? And in this case, I don't need a number because automatically it has to be number 1. There's no choice, right? Order of priority, this is going to be 1. Okay, why I've chosen this as 1 is if I choose this as 1, I can go clockwise, and this is 2, and this is 3. Okay, so whenever you're doing the cyclics, sometimes people are like, well, why didn't you make this one over here number 1? Then you could have made this one number 2. But then the problem is my double bond is between 1 and 6, and that can't happen. It always has to be between 2 consecutive numbers, like 1, 2, or between 2 and 3. So I made this 1 so that I could go this way and go 1, 2, 3, right? If I had made this one 1, which is my other option, I would have to go that way around the circle. And I don't want to go that way around the circle because then although this is at 1, this isn't until 6, so we don't want to have that. So cyclohex, then what you're going to find is right here you have that methyl group, and it is at carbon number 3. So for that reason, it's going to be a 3-methyl cyclohexene. Okay, so that's how your cyclics look. They're quite simple. We don't really talk about physical properties of cyclics because they vary so much from one to the next. So biggest piece is recognizing that it's cyclic because it has the name, right? And if you were doing the opposite and you're going from the name to the diagram, again, that good opportunity for you to practice some line diagrams, right? So I don't know, let's just say we had 2 ethyl cyclopropane. Why not? 2 ethyl cyclopropane. Okay, so we want to practice those line diagrams. So we start by finding our root like we always do. We see that it's a cycloprop. So that cycloprop is telling us that we have 3 carbons. So think about 3 carbons in a ring-like structure. You're coming up with that, right? So I don't even know why I wrote 2-ethyl propane. That shouldn't even be there. And that's just because I was making something up as I went. So why that doesn't need to be there is technically it would have been at 1, but really it doesn't matter because I only have one thing. And if we only have one thing, we don't need a number for it, okay? So you can pick whichever corner of that you want, and we're going to put in an ethyl. So we start at the corner, we go 1, 2, there's our ethyl cyclopropane.